Hi, so today we're going to go over the calculations that are done in thermodynamics for your chemistry class. This is the fourth video in the thermodynamics series, and this is just specifically about all of the calculations. If you haven't watched the other three videos, go ahead and do that first, so you'll know more about the calculations and how to do them. But this is just specifically how to know which calculation to use for in the word problems that you'll be given for your chemistry test. So heat energy comes in calories, in kilojoules, or in joules. In thermodynamics, we're going to be dealing mostly with kilojoules or joules of heat energy and not calories. Calories is done in specific chemistry experiments, and they do it to find out how much food heat energy is in food. So, but we're going to be dealing with kilojoules or joules today. Now, capital H is going to stand for heat, or heat energy more specifically. And a triangle, when you put a triangle in front of something, the triangle means a change in the amount of something. So anything that you put the triangle in front of is going to mean a change in the amount of that thing. So therefore, a triangle H is going to mean a change in the amount of heat energy. So that's referring to either heat given off during a reaction or heat absorbed during the reaction. Now, the heat energy in all the thermodynamics calculations, they're all geared to do one thing, and that is to calculate the amount of heat that is transferred either into or out of the system during the reaction. So either the substance absorbs heat or it gives off heat during the reaction. And the thermodynamics calculations, they're all to find out the exact same thing, and that's the change in heat, however much heat either escaped or was absorbed by the reaction. Now this is called, the amount of the change in heat is also called enthalpy. So the correct term to use, you can say delta H, the delta is the triangle, or you can say the change in heat energy or the change in heat, or you can just use the word enthalpy. It all means the same thing. Now this change in heat, or the enthalpy, it refers to the heat of the system, not of the surroundings. It refers to the actual substance or whatever reaction is taking place. It's not about if it got hotter in the air around it. It's about if that actual substance got hotter or gave off heat, got cooler, if it cooled down or if it got hotter. So the system, it's just a fancy way of saying whatever substance it is you're studying, or whatever substance you're doing a reaction with in the lab. So if the heat energy, if the enthalpy number, if the value is positive, then that system added heat energy to itself. It absorbed heat. It got hotter. And if it is negative, if the enthalpy value is negative, then the substance lost heat. It gave off heat into the environment and it cooled down itself. So if it gained heat and if the energy value is positive, if the enthalpy value is positive, that's called endothermic. Endothermic, because the heat went into the system. Endothermic. Now, if it gave off heat, if it cooled off, if the substance cooled off, the heat has to go somewhere. So that means the substance moved the heat out of, or the substance had heat moved out of itself and into the air around it. And so it gave off heat or released heat, and that's called exothermic. Exothermic, the heat exited from the substance. Exothermic. So that lost heat, and that's the negative enthalpy value. So here's an example. Is the following reaction endothermic or exothermic? And this is the perfect example of information that you could be given on a test or when you're working in the lab. See this reaction equation? This is a reaction, and you can tell it's a reaction because it has that yield arrow right there. So here's this reaction equation, and then along with the reaction equation, you're given this delta H, or this enthalpy value of, in this case, plus 252.8 kilojoules. Now, since this is a plus, since this is a positive enthalpy value, what would this be? It's a positive enthalpy value. That means it got hotter. That means it absorbed heat from the surroundings into itself. The heat went into the substance. So into the substance, that means the substance got hotter. Into the substance is endothermic. Endo, into, endo, same thing. So this would be endothermic. See, since the change in the heat energy is positive, here's the positive right here, and this is what we're talking about. That indicates the substance gained heat, it absorbed heat, so it's endothermic. Now here are the calculations that the three main calculations in thermodynamics that you're learning in General Intro to Chemistry. If you are given, now obviously there's more than this to thermodynamics, but these are the three big main types of calculations. You want to really make sure that you get these three down so you can understand it. And then there are other, I don't know if your teacher's including other calculations or not, but these are the three main ones that you're really going to need to know no matter who your teacher is. If you are given, see this column right here is this first column is if you are given, this is the information you'll be given in the test question. If you are given, and then over here on the second column, then this is the kind of calculation you want to use for that information. So number one, right here, if you are given a reaction equation, which we just saw one of those reaction equations, it has the yield arrow in it. So a reaction equation, and that reaction's change in heat, or that reaction's enthalpy value, that was the triangle H that we were just looking at for the endothermic or exothermic. And you're asked to find the change in heat, or the enthalpy value, for a specific amount of that substance. So if you're given a reaction equation and that reaction equation's enthalpy value, and you're asked to find another enthalpy value, depending on how much of the substance you're going to use in the formula in grams or moles, then what you want to use is the stoichiometry rules, and you want to use stoichiometry to solve the problem. Now, number two, if you are given the specific heat of a substance, its mass, and its change in temperature, remember I told you that you can put that triangle in front of anything, and it just means a change in the amount of that thing. So right here we got the triangle in front of temperature, so this would be the change in the amount of temperature. So specific heat capacity, the mass, and the change in temperature, and you're asked to find the heat, then you're going to use calorimetry. And really, if you're, the big clue on if you're going to use calorimetry is this first one, specific heat capacity. If you are given the specific heat of a substance, chances are you're going to use this formula right here, this calorimetry formula, because this is the only formula that takes into account the specific heat of something. So the calorimetry formula, Q equals capital C times lowercase m times delta T. That's capital C is specific heat, lowercase m is mass, and delta T is the change in temperature. Now number three, if you are given a reaction equation, you know, any chemical equation with the yield sign, a reaction equation, but you're not given without the change, the delta H, without the enthalpy value. You're just given the reaction equation itself, and you're asked to find that delta H, that enthalpy value, and you're given two similar reactions with those similar reactions enthalpy value. So you're given a reaction equation and you're asked to find that enthalpy value based on two other similar looking equations and their enthalpy values. Then you're going to use Hess's law, which is that puzzle game that we talked about in the third video. So let's look at a couple of word problems, and you don't have to solve these word problems in this video. We're just looking at what type of calculation to use. What type of calculation are we going to use for these word problems? So here's the first one. Calculate the amount of heat transferred with 24 grams of methanol according to this reaction. And you're given this reaction equation right here, and you're given this enthalpy value right here. Well, since you're given the reaction equation and you're given the enthalpy value, and then it asks you to calculate the enthalpy value for 24 grams of the substance, then you're going to use stoichiometry to solve this. This is just a stoichiometry problem. Now, if you're asked to find the enthalpy value of a reaction, you see you're given this reaction equation right here, but you're not given the enthalpy value. You're asked to find the enthalpy value, and you're asked to find the enthalpy value based on these two similar looking equations right here and their enthalpy values. See, you're not given the enthalpy value for the original reaction, but you are given the enthalpy values for two other similar looking equations. Then you're going to use Hess's law, that puzzle game that we talked about, to manipulate these around, rearrange these two similar equations, and using that to find the enthalpy value. Now here's another one. The specific heat of octane is 2.22 joules per grams times Kelvin. How many joules of heat are needed to raise the temperature of 80 grams of octane from 10 degrees to 25 degrees Celsius? Now, the big clue in this word problem is it gives you the specific heat. Specific heat and specific heat capacity are the same thing, just specific heat just is shorter, so a lot of people just say specific heat, but we're talking about the specific heat capacity. You're given the specific heat, so that automatically you should know that if you're given the specific heat, then this is a calorimetry problem, because there's only one formula in thermodynamics that takes into account the specific heat of a substance, and that's the Q equals C, capital C for specific heat, times lowercase m for mass, times delta T for the change in temperature. So you're given the specific heat of a substance, and that's this C right here in this formula. So this is the only formula that has specific heat in it, that takes specific heat into account. So you know automatically that you're going to use this calorimetry formula. Calorimetry.